All right, I'm going to go ahead and start showing, revealing the answers. Again, this is why are humans so good at throwing? And just read over them as they come in. All right, looks like we had some good thoughts and ideas there. I like the depth perception, and that's because anyone know what's interesting about the position of our eyes? What gives us our depth perception? The fact that what are our eyes doing?
Aren't they overlapping?
Yeah, they're both on the front of our face, and so they technically both eyes have similar fields of view, and that allows our brain to do a little math and pretty accurately judge how far away or how close something is. We have thumbs, very good. Why are thumbs helpful, though? You don't really explain why thumbs are helpful for throwing things. What can we do using our thumbs?
Grip things. Grip it.
Yeah, having a grip is really important. Throwing is fun. Yes, it is. It's why we do it in sports and things like that all the time. Needed for hunting. I like this, again, of evolutionary advantage as well. So evolutionarily speaking, yes, it was definitely an advantage for hunting, that rather than getting into hand-to-hand combat with your prey, you could throw things at it, you could harass it, you could kill it from a distance. And so apply that to evolution. If you've got individuals who figured this out, that they're good at throwing, they're throwing at prey, what do you think is true about how many animals they're killing? Anyone? Think they're killing more animals, less animals, bigger animals, smaller animals?
More.
Killing a lot more, which means they're eating a lot more, which probably means they're a little bit healthier. And what else are they going to be doing more than any other individual? If you're particularly healthy, you're also going to be doing what to pass on your genes?
Reproduce.
Reproducing, having more babies. And so this is most likely what was going on with some of our ancestors like Homo erectus and Homo neanderthalis, that they were figuring out how to use tools. These tools gave those individuals the advantage of having more food, being healthier, and reproducing more. They passed on the genes for those larger brains, those thinking brains, and they were able to get the energy to power the brain. And now we've got the largest weight to size ratio of any brain of any animal, and we use a ton of tools. But what's interesting is, in terms of evolution, we didn't evolve to be good throwers, though, right? I don't think that was the goal of having thumbs or having, a lot of you refer to the anatomy of a rotating shoulder. Our arms can be like slingshots. A lot of that is because our ancestors, we descended from monkeys and apes. Where do they tend to live? What are they very good at doing?
They're good at climbing.
Yeah, and so I think this, our ability to throw, is sort of an offshoot, like an unexpected benefit of our ability to climb. Right? That's what gave us our thumbs and our ability to grip things. That's what gave us our wrists that can rotate around. And so, just like how feathers evolved more for warmth, and then had this added benefit of contributing to flight in birds. So too, I think that a lot of our evolutionary features for climbing, now that we're not climbing trees, we're walking upright around. But we were able to then evolve into this very accurate throwing skill. And that became an advantage. So we'll watch a little video that's all about this, because it's interesting that some of you refer to monkeys and gorillas in particular. Does anyone know what monkeys in particular really like to throw around? It's kind of gross to think about, but they do it. They throw their poop around a lot. But on that note, I'm sure a lot of you have probably seen gorillas or chimpanzees in zoos and things like that. Are those animals good at throwing things? Are you worried about a gorilla throwing a rock at you from inside the zoo? They're not known for it. And so anyway, we'll watch a little kind of Edpuzzle video to explore this. So let me escape out of this here. So that's our bottom of this next task. Again, we're working on task number 3 here. There's an Edpuzzle video. It's just 4 minutes long. It's got 4 questions to it that I'd like you to watch. I know some of you, the Edpuzzle like freezes on the first question. So if that happens, I have just the normal video down on the bottom there that you can do. But I'll keep an eye on your progress. Again, I'll time us for probably about 8 minutes to complete this. And then we'll come together to review it. So 8 minutes to watch that Edpuzzle, answer the questions. I'll be here listening if something doesn't work, if you have questions. Go for it. All right, everybody. Looks like most of you have submitted the Edpuzzle. If not, you can keep working on it, but let's come back into the room together, please. So what'd you think? Does throwing make us human?
Kind of.
That's kind of interesting.
A lot of other things that make us human, but I guess throwing is one of them.
Yeah, this is definitely looking more like early evolution stuff and kind of what allowed us to become such efficient hunters. This is this guy, you know, this Dr. Roach, I think, this is his whole postdoctoral scholarship, everything. He's been researching this stuff. So kind of interesting that I like his acknowledgement that, you know, yes, baseball pitchers, football quarterbacks, those are all very talented. People are very good at throwing. But who else is good at throwing?
Everyone.
All of you, right? We have this sort of innate skill, which is kind of interesting. Can anyone tell me which animal, surprisingly, even though they're very closely related to us, is not good at throwing, according to him? That was the first question.
Like
Chimpanzees.
Yeah, chimpanzees, gorillas, all the apes, they, even though they are way stronger than we are, I mean, when you talk about power and muscle, they are in a whole other category, right? But they're not very good at throwing, and it comes down to their anatomy, right? We have a shoulder blades and the way that our arms are locked in, and I think it has to do with just our upright posture is what sort of gave us that advantage to be better throwers. I don't know if a lot of you watched that Tiger King documentary or what Netflix had out, but a lot of those guys had pet chimpanzees. Are those good pets to have?
no.
They'll rip your arm out or bite your finger off. Again, they're just very strong and they don't think anything of it. So they're definitely something you got to be wary about. The next question was about how do the tendons and ligaments in our arm contribute to this? What does he equate a lot of the muscles and ligaments in your arm to?
It's like an elastic band.
Yeah. Anyone seen those like pictures of a pitcher mid-throw? What do you notice about their arm?
All stretched out.
Yeah, it's kind of gross, isn't it? It looks broken. It's like behind them, but it's exactly what it is. It's like a string that has been pulled back, and then they're just going to whip it forward. And so it's exactly like that. It's like a rubber band, but imagine having hundreds of thousands of rubber bands all connected together. That's what your muscles are essentially made out of. That's what gives us a lot of the force that we're able to throw with the added accuracy. However, we look at, you know, athletes and, again, baseball pitchers and stuff. What's the difference between how they're throwing and what our ancestors were doing?
Well, they throw a lot more and maybe faster. But when our ancestors were, it was just to like hunt, and like other than like practicing their aim, if they did that.
Yes.
There wasn't really any for it.
Hopefully there was no caveman who was throwing a spear 100 times into a woolly mammoth at 90 miles per hour. But I don't know. I mean, there might have been a sicko out there like that, but no, that is not what they were doing. Plus, in baseball, right, the pitcher is not trying to kill and eat the batter. That would be interesting to watch, but that's not, you know, it's a sport, it's a game. But that's what leads to all those injuries, right? Your shoulder and your elbow are not really evolved to do that, and so that's why baseball pitchers often end up ruining their arms. Same thing happens to a lot of football players destroy themselves for a lot of different reasons, but quarterbacks definitely have a lot of arm issues and wrist issues from all the throwing they do. Last question then is, what is the difference with the projectile? So yes, we're throwing baseballs and footballs now, but what were our ancestors throwing?
Spears.
Rocks.
Yep. And that, again, there's some pivotal moment in human evolution where we figured out that picking up and hurling sharp sticks was a much more comfortable way and efficient way of hunting than trying to attack hand to hand. And so, anyway, kind of interesting moment about, you wonder where that started, and that's something a lot of these researchers are starting to do. So you are all very good at throwing because we have this innate ability. So the story I like to tell is from my Peace Corps days. When I was in the Peace Corps in West Africa, I lived in a rural African village for 2 years. And in addition to teaching, I started a garden in my compound. I made a couple garden beds, started planting a few vegetables, and I fertilized it all. I was really proud of my garden beds. But we also had chickens in the compound. And these chickens would come over to my garden bed. Does anyone know what chickens do when they're looking for bugs to eat?
Dig.
Yeah, they scratch. And so these chickens would get into my garden bed and they would scratch all of the fertilizer out of the bed. So I would come home and I would have these perfectly fertilized paths and no fertilizer in my garden bed. So I'd have to put it all back on. I built a fence around my garden. And again, the next day I came back and the chickens had still, jumped or flown over the fence. I got in there. I was so mad. I chased them out. I picked up a rock and I was like, all right, I'm going to scare one of these. There was a chicken running along a fence, and just in my anger, my brain did the math. I threw the rock ahead of the chicken because I was like, all right, if he keeps running, he's going to be right there. And I nailed this chicken in the head, like spot on. This thing falls on the ground, starts flopping everywhere. And I'm like, oh gosh, like I feel so bad. But also, these are meant for my host family to eat. These are their chickens. And they were a Muslim family. Muslims won't eat meat unless it's been ritually slaughtered, right? They have a way they have to kiss the knife, they say a prayer, and so I'm running to get my host father, like, oh, get a knife, you got to come, like I hurt this chicken. But luckily, when we came back to the field, the chicken had gotten up, was walking around again, so it was probably like concussed or something bad, but it was not dead, so it ended up being okay. But just I didn't play baseball in high school. I'm not very good at throwing things, and yet in that moment when I was angry, I was able to hit a fast-moving animal from a distance pretty accurately. So it shows that we have this sort of innate ability in us that we've inherited. But anyway, I never threw rocks at birds again after that, so I felt bad. Anyway, okay. So the next thing to do is, am I still coming through? Is the internet okay? My computer gave me a little warning. All right. So let's do an activity now. I'll let you sort of read through this yourselves. And I'll give us the next 20 minutes to do this, but essentially we are now on task number 4 right here. You're gonna be throwing a projectile yourself, and you can do this indoors or outdoors. I have instructions for both situations depending on where you are and what you can do. But you need to get 3 equal projectiles, so 3 tennis balls, or just get 3 balled up socks, or you can use sponges from under the sink, whatever you can find that you can throw, and then they should all be the same. And all you're doing is you're going to do 3 throws. You're going to throw from a 15-degree angle, which is basically vertical. You're going to throw from a 45-degree angle, right? So you're launching between horizontal and vertical, and you're going to throw at 75, which is almost straight up. And the goal of this is to figure out which one will have the greatest horizontal distance. So you're going to try to throw with the same amount of force. The activity I base this on says throw as hard as you can, but I would, be conscious of where you are, and if you're going to hit anything, watch out for that. So safety, again, please, don't hurt yourself, don't hurt your arm. Make sure there's no people or cars or windows or anything that you might break. But all the instructions are here, so just read through them. There's 2 things you need to do. There's a Canvas quiz that looks like this. There's about 6 questions to answer. The first one is a prediction, and then after that, it's just instructions and questions on what to do. And then there's also a Flipgrid video. I would like you to film yourself just doing 1 round of throws. So just one of each of the throws, that's all you have to film. But I would like you to do this 3 times just to get accuracy on your observations, but you only have to film one of them and post that just so I can see what you were throwing and where you were. So I will leave you to it. Again, all the instructions are there under number 4 on Canvas. I'm here listening. If you have questions or need help, we will use the next 20 minutes to do this, and I'll time that from here, and I'll just kind of give you reminders periodically. So, all right, go for it. I'll see you in 20 minutes. Let me know if you have questions.
How do we throw at those certain angles again? Like, how would we throw from 15 degrees and like?
You're just gonna have to take your best guess at it. You'll see in the videos that I post, but yeah, you're just sort of doing. You can do an overhand or underhand toss. Probably overhand's gonna make more sense, and you just want to try to launch the ball a little bit above horizontal. That's 15 degrees, equally between horizontal, vertical, and almost vertical. So you can practice a few times, but I know it's not going to be spot on.
All right, thank you. Should we take the quiz or no?
Yeah, that's what you're completing. The Canvas, it's U4L16. How far can you throw? Yeah, that's one thing you'll be completing. And then there's also a Flipgrid video to post.
Okay.
All right, kiddos, that's 20 minutes. Come back into the room, please. Looks like we had 12 postings for the videos, which is great. Just one of you needs to finish that. If you ever have trouble uploading to Flipgrid, just know that you can also just email me videos and just let me know. I can always grade them that way. And it looks like at least 8 or 9 of you were able to submit the whole Canvas quiz. You don't have to finish that. That can roll into homework, so take your time on finishing that. But be honest. So how many of you, what was your prediction? Which angle did you think was going to give you the most horizontal distance?
45.
45.
Most people went 45. It's kind of interesting though, because do baseball pitchers throw at 45 degrees?
No, but it's different because like as far as you're like if you throw out 15, it'll get to the destination faster. But like as far as like total like destination, it's different.
Yep. Yeah, baseball pitches are all about speed, right? And in fact, as far as I know, a pitcher up on a mound is technically kind of throwing downwards. The batter's a little bit lower than where they end up being, I think. So yes, it is indeed 45 that ends up giving you the most distance, and that kind of, if you think about it, it makes sense. It kind of optimizes both the altitude and the distance. And then if you go onto the PhET simulator really quickly, it's a really nice image of that. And that was the first thing I did when I started reading about this activity. But you can see here really clearly, since we're launching even 10 meters up, at 15 degrees, it just immediately starts to fall, right? It's in fact probably falls over a shorter time period as well. 45 degrees gives you the best, and then 75, it's just too much altitude, not enough range, right? It doesn't travel far enough. And so in terms of, I keep using baseball as an example, but pitchers aren't throwing at 45 degrees, but anyone want to guess what angle batters try to achieve when they're hitting the ball?
45.
Yeah, it's close. I think it's a little more. It's usually in the 50s, but that is what really allows them to like hit a home run, right? Because the batter, they want to maximize the horizontal distance. They want to hit the ball as far as they can, and so that they hit it at a much sharper angle, that halfway in between. So this was just a silly activity to explore that a little bit. So homework is just to complete any parts of that you didn't finish now. Hopefully you were most of the way done with that. As I said at the start of class, I would like you to fill out a very small survey on Canvas, which is just called the Final Rube Goldberg Machine Initial Plan. It's literally just 2 questions. Looks like this. The first question is, again, just choose which 4 tasks you think you would like to do. Again, it's not set in stone. You can change your mind. But I just want to get an idea for each of you about what 4 tasks you want to do, and then how you're going to do each of those tasks with what you've got at home. So start to plan out, like, what can I actually use to make this final, more permanent machine that will hopefully run repeatedly and consistently. That's what we're going to work on over the next couple of weeks. The final thing is your spring midterm comments, and you might have seen these in your other classes. I know we already posted midterm grades, but we've now written comments that are more a reflection on how you're doing in the online learning, remote learning environment. And so to access those, just to show you, again, it might be similar to what your other teachers are doing or not, but you're going to want to go to your Google Drive. And if you're not sure how to do that, then you just, on your homepage, you click on the waffle, go to your drive, and you're going to want to look in the shared with me category, which is in this left set of options here. You have like priority, my drive, whatever, but you want to go shared with me. And you'll have a bunch of stuff in there. various documents, stuff you've used for other classes or whatever, but what you're looking for is a Google Doc with the title of your last name, your first name, and then some kind of code. For you, for science, it'll be 523-3. So that's what you're looking for there. When you open that up, I won't show you anyone's in particular because it's private stuff, but I'll have your current grade, which you can also see on Canvas. I'll have a short little paragraph that I wrote just about, what's going well for you, what probably needs a little bit more work, what missing assignments you have, and what you can do to make up those missing assignments and improve your grade. And the final paragraph says to respond or reflect on this feedback, answer the questions in this student response reflection Google Doc. I made a Google Doc for each of you. And so if you click on that, it'll take you to a doc that, again, also has your last name, first name, and in the title. And it's just 6 questions. This was put out by the administration here at Stevenson. And it's just questions about, how do you feel about the comment? Was it accurate? What's going well in the class, and that sort of thing. Helpful feedback for me. I am offering you 10 assessment points for this. So this is basically worth a 10-point quiz or test grade. So that'll hopefully motivate you to do this. You don't want to get a 0 on that. It's a nice, easy 10 points to boost your assessment average. So that is also your homework for Thursday. And we'll check in again on that when we meet again too. Any questions on that? All right, that's it for me, kiddos. I'll hang out here in the room if you have any questions or want to talk about anything in particular. But otherwise, thank you very much. Have a good day.
Thank you.